The tail is what matters. If you go out and read the literature on convergence tests and the like, you'll sometimes find that those theorems are written in a way that's a bit more vague than we're used to. So the comparison test. If a sub n is between 0 and b sub n for all n, and the series sum of the b sub n's converges, then this series, the sum of the a sub n's, converges as well. Do you see what's missing? Well, I didn't write the sum n goes from 1 to infinity of b sub n, or the sum n goes from 1 to infinity of a sub n. But this is actually okay. Here's a theorem. Let big M be a natural number, then this series, the sum little m goes from big M to infinity of a sub m, converges if and only if this series, the sum little m goes from 1 to infinity of a sub m, converges. In short, convergence depends on the tail. So I've got this series, the sum little m goes from 1 to infinity of a sub m, and I can start writing it out like this. It's a sub 1 plus a sub 2, blah, 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 plus a sub big M minus 1, plus a sub big M, plus a sub big M plus 1, plus and so on. And I can take out my scissors of mathematics and cut this series like this. This piece here I'll call the head, and what's left over, which is really the sum little m goes from big M to infinity of a sub m, this is the tail. And what the theorem tells me is that this series converges if and only if this series converges. So convergence only depends on the tail. Why does convergence only depend on the tail? Well, let's suppose that this tail converges. That means something about the sequence of partial sums. What that means is that if I consider the sequence of partial sums, S sub n equals the sum little m from big M to n of a sub little m, that sequence of partial sums converges to something, I'll call it big L. That's the value of this series. I can relate those partial sums to the partial sums for the series that begins with a sub 1. So now let's think about this series, right? The series little m goes from 1 to infinity of a sub m. The value of this series is by definition the limit of the partial sums for that series, and that's the limit little n goes to infinity of the sum little m goes from 1 to little n of a sub m. Now I can analyze this in terms of the series that starts at big M. Right? What is this limit? Well, that limit is a sub 1 plus dot 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 plus a sub big M minus 1 plus this limit, the limit little n goes to infinity of the sum little m from big M to little n of a sub m. Right? Both of these are just the limits of the sum of the terms a sub 1 through a sub n. But now I'm assuming that this limit exists because I'm assuming that that series that starts at big M converges. That's the limit of the partial sums for that series, which I was calling L before, which is just to say that this series has a finite value, right? This limit exists. And what that means is that if I suppose that the tail of a series converges, then the original series converges as well. Here's the upshot. If you only care about convergence, writing down this, just the sum over n of a sub n, is just as good as writing down this more complicated looking thing, the sum little n goes from 1 to infinity of a sub n. Because if all I care about is convergence, I don't actually need to know where the series is starting. Because regardless of where I start the series, they all converge or they all diverge. It only depends on the tail.